Our objective is to do some session on machine learning. Today we are going to take up a data set, this students course data set that I have downloaded. I will give you the link if you want to download it yourself, or maybe I can share it. I'm okay with both of them. Okay. So before we start, I must tell you that the main agenda today is to cover a few things, like what are trend test states, what is a learning algorithm, which learning algorithm to use, what techniques to apply, what to check, and so on. Okay. So at first we have to load our datasets. Okay. So two libraries that are going to be very important while we are doing machine learning is one is NumPy and another is Pandas. Okay. So we are going to import them using this command import NumPy. And since NumPy name is a little big, to make it short we use as NP. So as is we create an alias, okay, a short name for a bigger name. Okay. And another library that we are going to use is called Pandas. Both of these are very famous Python libraries vastly used by industry people, academia, and all over the world for machine learning and data manipulation and things like that. And we are going to see how to use them. Okay, so I just run this cell. So what we are going to do is we are going to import everything, all our libraries here. Okay. Okay. Now let's start. So at first we are going to load our dataset. So I am going to name a variable called data, and we are going to load the dataset using the read CSV command of Pandas. Okay. So here we are just taking the function read CSV from Pandas by mentioning pd.readcsv, and we will just import students underscore scores, just the name of the file that we have stored downloaded. Okay. Students underscore scores CSV. Oh, why not found? Why? I think I have taken a wrong name. So it's student underscore scores, not students. So it is case specific. Okay. You have to be like very specific with the name, or else it will throw an error. Okay. So let's have a look at this dataset. See, we have some rows of data. This is extremely small data set. Actually, in like when you are solving some real life problem, the data sets are going to be quite big. Okay, in some maybe in thousands, if not in millions. Okay, so we just want to take a look. So we will use the head command of Pandas. So this thing is called a Pandas data frame. Okay, it is similar to Excel, which has been replicated in the form of a table in Pandas. It basically reads from CSVs, it reads from Excel files and converts these tables into data frames. And these data frames are extremely helpful when we are doing any machine learning task. Okay, so it's data.head. We see the first 5 rows of our dataset. So if you want to see the last 5 rows of our dataset, we can do a data.tail. Okay. So this is how we get a glimpse of the data. Now, what we want to do, we want to predict the scores based on the number of hours studied. So basically, this dataset is telling us that the number of hours the students studied and what are their scores. So basically, this hours becomes our x and this scores becomes our y. Just like think of it as an equation. Okay, like this. I will write down the equation here. Okay. Now let's say I write it like this: y equals f of x. Okay, so this is the function. Okay, so what we are doing, we are supplying x and we are obtaining an output, but we don't know what this f is, how this f looks, what is this f that we are going to use. F can be of any form. Okay, so for that we need to run our algorithm over this data set and figure that out. Okay, that will be figured out by our model. Okay, now what we do is we do a basic info check of our data set. So how do we know what kind of data we have? To get a glimpse of that, we can do a data.info. Okay. So we get the information of our data. We see that there are 25 rows of data, non-null. There is no null value. Okay, those are all of float type. Float means, I have taught you, this is a basic data type in Python. Like a decimal, it shows decimal representation. And we have the scores, which are integers. These are integer values. Okay, these are not in decimal places. These are all rounded off to integer value. Okay, basically because the scores that are given to students are usually in the form of an integer. Okay, the percentage can be in decimal places, but the scores are usually in this form. Okay, integer. Okay, so we know the information. Now, as I said that we are using some x, we are trying to predict y. So this y is also given to us, the x is also given to us. This is the x and this is the y. We have to just learn this function f so that we can in the future predict whatever x that comes, we can predict its output. Okay, it is not going to be the entire data that is going to be generated. Okay, more data is going to be generated in the future. Maybe someone may have studied say 12 hours, then what is going to be the output? We don't have any 12 hours here, right? So we have to learn it in such a way, in a generalized manner, that it can predict for any value of x, it can predict the output, that is the score. Okay, now before we move on to the modeling, we have to understand what kind of data that we have. Okay, for that it is very necessary for us to see some statistics. Statistics is an integral part of data science. Data science is nothing but a programming wrapper over statistics. Okay, so for seeing some visualizations, we will use another library called matplotlib. Okay, matplotlib.pyplot as plt. We just give it a short name. Now let's see how our data looks like. Okay, so say I just got it. PLT is the name of we have imported the like matplotlib library as PLT. Now we use plt.plot, and we have to supply the values of x and the y. Okay, so I will tell you a trick. So there are a lot of functions in data science that you will come across in your entire life. We can't cover everything, right? Every day a new library is coming up and everything is coming up. So the best way to learn about any library is to read its official documentation. You can access the documentation in Jupyter Notebooks very easily using Shift and Tab. Okay, see here the documentations have been given. Plot y versus x as lines or markers. Okay, so we have to supply the x, we have to supply the y, and so on. Okay, there are other various other kinds of functionalities as well, but we will use a very basic one for now. Now let's see. So our x is hours. So let's plot data to access any row, we use this third bracket with the variable name. So we give the column name. Column name is ours. Okay. So this is a basic way of accessing any row in any column. You have to give the column name inside the third bracket inside the data frame name. Okay. To access the score column, we will just use a similar function, similar method, I mean, and that's it. Now we will just plot it. Now what happened? Oh, this is scores actually. These names have to be very specific. Okay. Here the graph is not a very pleasant one, so it is better that we plot a. Okay. So this looks much better. So we are using this O. We have just converted this into a scattered kind of a plot with dots. Okay. You can even change the colors. Say you want a red color. So I give it R red. So I give it R for red. So I just run it and see the color change. You can play around all these parameters. Okay. Now we see this is in the form of a straight line, almost a straight line. See. The parameters with number of hours studied is changing linearly. As the number of hours are increasing, the scores obtained by students are also increasing. Okay, so what we do, we have to select any kind of algorithm that does linear kind of a prediction. So before we move on to that, I will just label these parts. Okay, now see, the labels has changed. I have just added the x level as ours, so here it appeared ours. So I have added the y level as scores, so it appeared as scores. And I have used this plt.show because other than that, before that it was showing it as an object, so I just wanted to remove that. Nothing wrong in not removing it. And I have just added the title as hours versus scores, the number of hours a person has studied versus scores. You can use any string here to represent your title. So I can say studied hours versus scores. Okay. Okay. Now this is the thing that we have come up with. We are seeing that there is some linear relationship between the hours studied and the scores. Okay. So what it is happening? So we have to come up with an algorithm that takes into account this pattern. Okay. So there is an algorithm named linear regression in machine learning, which is basically a linear line that it tries to fit using the straight line equation. You all know the straight line equation, right? The straight line equation is of the form y equals mx plus c, right? You have all learned this in 10th standards, in 11th and 12th, right? So what we will do is try to fit a line through this, but what our algorithm will do is try to learn these values of m and c. Okay, in such a way that the line is in such a way that there is no difference. The distance from the line from each point is very less. How do we optimize our algorithms? We optimize our algorithms by using a cost function or a loss function. Okay, so I will not get into loss function or cost function in very detail in this video. Cost function is basically, you can say, is some metric. Is a metric for evaluation. So in order to evaluate how our model is performing, we need some metric, right? And that metric has to be something that can quantify it. And one of them is the least square distance. Say when we are fitting a line through this one, we will try to see what is the distance of this line and the point corresponding to it. Okay, so we compute that distance, and when the distance is the smallest, when no further changes can be made to that line, then we will say that is the best fit, and we will take that as our model. Okay. But don't worry, we don't have to explicitly do all of these. We have libraries for that. We will be using the linear regression library from sklearn. Though the basic fundamental concept behind using machine learning is we have to be very we have to minimize the cost function. Okay, so the cost function looks somewhat like this that we will be using. Cost function is going to be somewhat like square root of x2 minus x1. Okay, and we take the square. Where is the square? Okay, so this is going to be the cost function. So when we fit a line through it, we will have some value of x, okay, corresponding to this, okay, and there is going to be some value corresponding to this, okay. So yeah, so just have a look into this, and I will come back. Just have a look. So I hope you have had a look into this. I'm sorry, this is not only this has to be added apart. Yeah, So this looks better now. Actually, this is the formula that we used in our school days to calculate the distance between 2 points. Remember, where there was one coordinate x1, y1 and another coordinate x2, y2. Okay, so that is what we use as our cost function, as the distance between the predicted point and the actual point. Okay, so that is it. Okay, so now what we do is basically we keep okay, so this is it. So when we fit a line through this, what we do is basically compute this and we try to minimize this. Okay, and how do we minimize this? We just keep changing the parameter values, that is m and c, and see how it is reducing, and we keep the value of m and c for which we get the lowest cost value. Okay, so that is how algorithm works. Now we go into the modeling part. Okay, so we will now use a library called sklearn, and we will import certain things from there. From sklearn dot linear model. Since linear regression is a linear model, it is in that module. Okay, sklearn is a big library. It has many submodules, and linear model is another submodule within which we will import the linear regression function. From sklearn, well, sorry, actually I had to attend one call. That matrix. So matrix, what we are going to do is we are going to import the root mean square. That is this thing that we are going to import. Root. Sorry, I guess they don't have root mean square. They have mean square error. Yeah, they have mean square error, I guess. Yeah. So this is mean square error. Okay. And what we are going to need is another thing called the train test fit function. Okay, so we have got the train test fit function. Okay, okay. Now comes the main part. Okay, so we will just run everything again, just for confirmation. Okay, now we are ready to run our model. So before we run our model, I have to make one concept very clear: train test fit. So what is train test fit? Basically, when we are like training a model, we are basically training it on a set of data and testing. But because training and testing is like, say I told you that I'm going to take a test on maths say tomorrow. So what do? You learn all the examples from your book and you get prepared. Okay, and the next day I can give you questions that you may not have practiced or you may have practiced. Okay, so how do I test that how well you have prepared yourself? To do that, what we do is we train our model on a set of data and we keep a set completely separated, on which we will test how the model is performing on an unseen data. To do that, we just do this. Let's keep the training and testing separately. Okay, so what we do is I at first use the train test fit function that I have imported, and at first I will have to pass the x values, that is the independent variables. Here there is only one independent variable, that is ours, and then we have to supply the dependent variable, that is scores. Okay, then we have to supply a parameter called test size. What is going to be your test size? Since we have a very small data, I will take only say 20% as my test data, so 0. Okay, and it returns a series of values, that is x train, comma x test, comma y train, comma y test. Okay, and we run it. See, now it has been divided into two parts: one with the training independent variables and training dependent variables, and another part with the training independent variable, testing independent variables and testing dependent variables. Okay, now what we will do is we will basically train our model using the train set, training x train and y train, and we will not touch anything from x test and y test. Okay, so we will say model dot. Okay, so we will make an instance. So basically these models are actually classes. As I told you, in classes we just these models are all made using classes. So we make a object of the class and we call the fit method. Model dot fit. We just say x train, comma y train. Okay, we are saying that based on these x train features, these are called features. These x values, the values which are independent, which are used like this x is a independent, and we call them features. And the thing that we are trying to predict, that is scores, it is known as a label. So anything that is used for predicting something or estimating something in machine learning scenario, we call them features, and the thing that we are trying to predict or we are trying to estimate is known as the labels. Okay, so the score is the label here and the ours is the features. Okay, so we use train x train as our features and y train as our labels. So this is the format you have to follow in order to create your machine learning model. So I have mentioned x train, I have mentioned y train, and that is it. And you just run this cell. Okay. Okay, actually there is some because these libraries actually expects a lot of actually all these libraries have been built in such a way that they accept multiple features. Since our data set is a very beginner friendly data set and it contains only a single feature, so it gets through an error saying that if you have a single feature, just reshape it to a 2D array so that we can understand this is a single feature. Okay, now it is done. So basically the model has been fit. Now all we need to do is test how the model is performing. So how we are going to see the performance of our model? We are going to see the performance of our model using the metric mean square error. Okay, so we are going to take the root of this mean square error and we will get this value, that is the root mean square error. Okay, so basically now we will just predict. So I will create a variable named predict to store the predictions, and I will call model the object that we have created using linear regression, and say predict, and we will use the independent variables of the test set. Now we will use the test set to test how our model did. Okay, so we will just pass x test, and we will not use y test. We will use y test only to evaluate how our model did. Okay. Now let's see. Again, yeah. So we again need to do that reshaping thing. Okay, now the predictions have been generated. See, so these are the values that we have got, and let's see the original ones. Okay, so the original y test is found to be 86. Okay, we have got 80 close. 75, 87 is not very close. This is 30, but it has predicted it to be 37. It is 18 and it's 94. It's 47, but it's 53. Okay, now let's see what is the score that we have got using mean square error. So mean square error actually takes two values, two arrays, y true and y predicted. The true values that we have stored, that is y test. The y test is the true value, and predict is the thing that we have stored our predictions. So it is giving a value of mean square value of 67. So we just take the square root of this. We can use the np, that is numpy dot square root function. Okay, so this is 8. So this basically means that the distance from the predicted and the original values on an average is 8 units, you may say. Okay, so I think this model can do even better because the data is very small. We are somewhat restricted to the kind of prediction it generated. It is not that great, but yes, it does the job. We get a good estimate of how the student might score. Okay, so this is the mean square error. What we are doing is basically just doing this. Say this is the predicted value that we have got. We just copying it, and this is original value is 86. So I'm just doing 86 minus this value, and I'm just squaring it. Okay, squaring it, and see I've got this 27, and we are just summing it up for everything. But again, we are doing the same thing we are doing a plus, and then we are after doing it for this 187 minus 75 square, and we keep adding for all the value points, and at last we take a root. Okay, so and we also divide by n. Okay, to take the average value. The number of data points here is 1, 2, 3, 4, 5, so we divide by 5. So that is how we arrive at this score 8. Okay, this gives us a very idea of how the model actually performed, and it gives us a sense that how the predictions are, how good it is. We can have many other kinds of metrics for evaluation. Say we use say mean absolute percentage error. This is a different thing where we don't take the square, we take the absolute value. So this is other than just taking the square, they just subtract from each other and take the mod value, and then take the summation and divide by n, and generates a that is the absolute error. But absolute mean percentage error is something that generates the percentage of error on an average. Okay, so if I say mean percentage error, so I pass y test and predict. So what we get is on an average it is producing an error of 13%. Okay, on each data point it has an error of 13%, which is I think quite large. Okay, which is not a great model. So we can keep improving our model using various other models that we will see in the coming days. Okay, so this was a regression problem where we are trying to predict a continuous value. There is no class or group that we are trying to predict. So that is it. And this cost function is basically what we are trying to optimize while we are getting these values of m and c. So we can see if you see model dot just do where is the model dot parameter is it? Yeah, model intercept. See, intercept is the c value here. This is called the intercept, and this is the slope. Okay, so this is called as coefficient. Okay, so this is the coefficient of 10. So basically, if you do, if you just multiply this 10.09 multiplied by say any value of x, you just take a person who has studied 24 hours. Okay, just multiply 24. Just add the coefficient intercept, that is 2.033. Okay, see. Okay, coefficient. Am I doing something wrong? Oh, is it? Oh, sorry, this is the index number. This is not the number of hours studied. Okay, 24 hours studying is really a difficult thing. I'm just okay. So I think we need to see the x test corresponding to this one. Sorry. What happened? Oh, okay. So it's 7.8. 7.8. Just wait. I will replace this with 7.8. And see, it's 80.73. And see, it's that. I've just not considered all the decimal, or else we would have got this answer. So basically, what it does is just the prediction. The model is nothing but a mathematical equation where we are just trying to estimate the parameter values and use it in your equation. And the parameters are being generated in such a way that it captures most of the information. The losses, the difference between the actual value and the predicted value is so less, and that we are doing it on the training set. On the training set, we are predicting one point, checking it, and again optimizing it, predicting it, checking it, again optimizing it, and that way we achieve the best fit, and then we say that our model is trained. Okay, and that is how it is done. And I hope I've been able to like clear the whole thing for you. And if you have any doubt, you can let me know. I will try to clear it in our next class. But I think that is pretty much it. That is how you do predictions for any large data set. Also, we can do the same thing. But there are various complex problems that you will maybe come across in your entire data science career. And this is just a very small and easy data set that we have predicted. And I think that's it. That is pretty much okay. So that is pretty much it. Okay, so this is it. I'm sorry, but another thing I wanted to mention is this is not the cost function. This is basically the distance. This is the Euclidean distance. Euclidean distance. Okay, the cost function is similar to this, but not exactly this. The cost function is just this part, where we just compare the outputs. Various like models have various cost function. You can read about them in the internet. There are various kinds of cost function. Neural networks have different cost function. Though neural networks are not part of this course, I just wanted to let you know so that you can have a intuition of what cost function actually is. So I think if you want a class on cost function, you can let the authorities know. Maybe then I can come up with one, because cost function, the details and the mathematics behind it is actually very big. And if you really want it, then I can create a separate video for that. Okay, so that's it for today. Thank you. Okay, sorry. I'm just writing it distance or distance formula, whatever. Just the distance. Yeah, so that is it. And see you in the next class. Okay, bye bye.
questions and solutions.